Okay. Yeah. So yeah, let's start. So today we'll start a new topic, a new tool, which is called Docker. So you may have heard of it, but let's see what is it today. Let's take an example first before going to Docker at all. Let's take an example first, and let's see why it is required. You remember, I think in Linux class somewhere, I told about star methodology. So star methodology is something like I'll explain it one way online. It's a way like to analyze your problem and find a solution, take an action on that. This STR, they have full forms. Do it. I think in some class I told. Let's take that methodology now. Let's say I'm a developer and I'm writing some code and I've done with my code. I finished it. So usually what I did, I tested my local laptop obviously. So I did that. So it worked fine. So no worries. Now what I have to do that now, I have to deploy in some test environment or after that I have to move to production, right? That's the ultimate goal. So I have Jenkins pipeline. I push my code in the Jenkins pipeline, ran, and it deployed to some server, some environment, test environment. So now in the test environment, it's not working. The DevOps guy, some other guy, like the DevOps guy came in picture like, hey, the code whatever written is not working here in this test environment. But developer said it's working in my machine, it's working in my laptop wherever I'm developed it. But why it's not working here? That's the common question, right? So whose mistake is this now? The developer mistakes? No, it's working in his laptop, so in his machine, so it's fine. It's not his issue, and it's not working in the test environment. So we didn't do anything extra for test environment. I mean, the devs guy did nothing, you know, to make it not working, something like that. But whose mistake is this? There is no one's mistake here. The mistake, I don't say mistake, don't say it mistake. The difference. So why this situation happens is different environments, different, it can be different operating systems, different module versions, different dependencies due to, let's say I'm developer, right? So I'm using Mac OS. I'm using some Java code, let's say as an example, Java 11 or just Java 15, let's say. Java 15 I'm using. I written latest modules and everything. I mean, latest uh, version of modules. I'm using all of them from within my code. But in the server, in Linux, I mean, the server wherever we're deploying the test, it can be Linux or Windows, it does not matter for now. So in server, Java 11 is being used. It's a little older, right? Obviously, I'm using 15. I'm a developer, I'm using 15. And server, they're using 11. So obviously, compatibility issue came here. So how to resolve that? Either we have to tell developer, hey, downgrade to 11 version and use it. But no, that's not a good solution because obviously we have to keep with the latest technologies. We have to make sure our application is secure now with the latest technologies. Because once you keep on upgrading and once you keep on getting the new versions, if you still stuck at the old version, the features whatever they are providing, and you won't see those. And as well as there will be some vulnerability, just like in iPhone. If there is a new version, they'll purposely give an update to old phones, old version of phones. That update will slow down the battery performance and everything, so that they'll switch to the new one. I'm just saying as an example. So similarly here also, you have to make sure you update to new version always. So we can't tell developer, hey, downgrade. let's take scenario from this side also. Let's tell the DevOps guy to upgrade the version in the test environment. There also we cannot do because there are other applications which are using Java 11. So if they want to upgrade to Java 15 just for my application, other applications will affect if they're running in the same machine. The three applications are running. There two are using Java 11, and my application is going to use Java 15. So those two will affect if I upgrade a version. So at the time, what to do? This is a very common scenario everyone will see. Maybe not maybe recently, before maybe let's say 5 years before, 5 years ago, everyone sees this issue, especially between testers and developers. This is a common issue in every office. Even we face this. We means DevOps guys. So it's a common thing we generally see. So then what to do for this? We can't update. We can tell developer to downgrade it. What is the solution? So we have to install it separately Java 15, I mean the new version, and run the application only. I mean run only my application in Java 15. Correct? That's what we have to do. Let's say it's not possible to have Java two versions of Java. It is not. It is possible to install two versions of Java, but at a time we cannot use two versions. So what to do now? So what is the solution? Why? Because I mean, the solution is isolation. Correct? So Java 11, the applications two are using, let them use Java 11 only. But for me, Java 15 is required. So I want Java 15, but I don't want to disturb them, whatever they are using. So my application should be isolated. You know what is isolation, right? So I want my application to be in isolated mode so that this won't affect the other things. How to do that? There was a way called virtual machines. You know what is virtual machine? So virtual machine, a VM simply. So let's say in my laptop, a VM actually is a software. A virtual machine is software actually we install in our servers anyway. Let's say Windows to install any operating systems. We call them guest operating systems. So that within same machine you can use multiple operating systems. So we can able to run multiple operating systems. It means we can able to run multiple applications, right? In my let's say this is my laptop, right? Windows. I am running Java 11 here. My application is running here. Now 15 I need. I can install 15, but I can't use 11 and 15 at the same time. That's not the case. So I'll install another OS within this system only, within this server only, within this machine only to handle the Java 15. We call them VMs, virtual machines, or guest virtual machine or guest OS. So this is how the VM structure looks like. Let's get a better image. No, no, don't compare it. Yeah, maybe this will be good. Yeah, this is the image. This is our infrastructure is our let's say our machine, and these are our VMs, right? So like let's say example Oracle VM Box or VMware Workstation, VMware Player something. So there are tools. These are all the tools actually, which provides you the capability to create virtual machines, to manage them. So there is something called hypervisor. This is the program actually which runs within our system, within our machine, which handles these VMs. This is the one which differentiate between infrastructure and VMs. So in this scenario, three applications, correct? See, one is two are Java 11, let's say, one is Java 15, or let's say Java 11, 12, 13, 15. So this is my infrastructure. I mean my machine. In my machine, I have installed a software called Hypervisor. So and I'll install the virtual machine. Virtual machine is just like installing an operating system simply. So you install a software and install the OS. It's like completely new operating system, completely new within the existing operating system. Do you remember that? So it's completely new operating system within the existing one. So why these VMs are required? Because we want to isolation, right? We want to run multiple applications within the same machine. So at the time these VMs came into the picture. You may ask like, can we get a new machine simply just run this over there? That's simple solution, right? But cost is involved. Cost, the major one of the major things usually everyone sees is cost, and of course maintenance also. And they want to run in only single machine. That's why this scenario came. Virtual machines, I think, in the market from long back. I don't know. So even I'm not sure about the year. Let's say virtual machine or not what? Yeah. Let's go to wiki page. Did they have a year or something? Nope. They don't have any year. I'm not sure. When this was started. Yeah. Sorry. That's okay. It's not required. So yeah, this one. Now with this VM, my requirement is clear now. My requirement is done. So I'll create a new VM in the server in the machine, and I'll install Java 15 over there in the machine and run my application. So now it will work, right? In my laptop, Java 15 is working, but in server, I mean the test environment is not working because of version changes, compatibility issues. Java 11 is there. So what I do, I created a new virtual machine and I install Java 15 my platform over there and run the application. So it works fine, full. No issues with that. All good. So now it is fine. We creating a VMs. We are using it. How to create a VM is, well, I'll just keep it simple. First, you install a software. There are multiple software. You install any of the software. You have to download the ISO file. If you install a OS, you need an ISO file. So you have to download that. It will be around 3 or 4 GB. Maybe for Windows, I think it will be 8. For Linux, it will be 3, 4, 5, something in between that GBs. So I have to load that ISO file and install it because we are creating a new operating system. That's why that's whatever required for operating system. All those required for a VM also because it's just like another operating system within the operating system. That's it. OS within OS. If you take your laptop to your laptop is corrupted if you're not opening. So if you go to internet shop, what they'll say, OS is corrupted, we have to reinstall it. We have to install the OS. They'll simply put a CD or not nowadays no CDs, but earlier they'll put a CD or pen drive. The OS will be there in that, and they'll install it. Similarly, VMs, pen drive, and all not required. So you just download the ISO file and you install it. While installing, you choose what you do is while installing, you will see you'll assign for this VM how much resources are required. Let's say 3 VMs are there, right? My infrastructure is 15 GB. Let's say, 15 GB RAM, 500 GB hard disk. Let's say 16 GB RAM. Sorry. So I'll give two each. Two GB RAM, 2 GB RAM, 2 GB RAM. 6 here and 10 for my server. Sorry, I mean my machine, my host machine. So from the host machine, you are giving some resources to the operating system. Why? Because the guest OS, I mean, the VM is running here only, right? So you need to give the from the host to the container. So like this 6 GB here you gave, and maybe hard disk 100 GB. Sorry, 100 again. It's fine, all good. And now you ran the application. That's it. So now application is running fine in the VMs, all good, no worries. But I'm seeing few problems here. Not a problem, I would say limitations. So in VM, what is the thing? First thing, what is the first problem? Is the size. Since we are installing the OS, a new OS in the virtual machine, the size obviously will be huge. You need minimum 30 GB to install an operating system because 4 GB itself, the ISO file, when you load it for for any OS, or let's say while installing any operating system, there are so many dependencies, so many modules that will install by default. Even though majority of them we don't use, but it will download as part of package, while installing it. So due to that, the size became very huge. Let's say, for example, Ubuntu image or CentOS, CentOS OS, CentOS or Ubuntu, they require 30 GB or 20 GB minimum. Otherwise, it won't work because that many dependencies it will download, even though we don't use it, and we cannot skip it. We don't have an option to skip this module. I don't use something like that. It will install. So the size is huge. Another is speed. The loading is a problem. See, VM, as I told you again, it's nothing but an operating system, right? Correct. That's what I mean. That's what it will. That we are installing. Sorry. So when you start a VM, it means you're starting an operating system, just like Windows or Linux. So it usually takes time. So that's speed. And let's say the RAM is 2 GB for now. It is not required. We can increase it. If it is not, we increase to 4. Let's say 4 also not enough for some reason because your application is taking too much. We increase again to 6 for this VM alone. But you have to make sure our host system machine is also have the enough resources to handle that. See, host system also need to load, right? Let's say my Windows laptop, it needs to load in order to run the VMs, right? So if there is not enough memory here, how you'll assign to here? You can't. That's one issue. Speed. There is another issue is, let's say you assign 2 GB RAM to with API here, but the API is using only 1 GB. Very rarely it is using 2 GB. Very rarely, maybe once in a month. So you're wasting 1 GB here, right? You some resource you're wasting here. So what you thought is, okay, it's using only 1 GB every day, but only on one day particularly, it's using 2 GB. So my what I thought is, let's reduce the size to 1 GB, and whenever required, we can increase it. How to increase? Again, manually. There is no option to automate that. So the resources are not being used efficiently by the VMs, virtual machines. That's one thing. I told three things. What is that? Size, huge, speed, it is slow. The wasting resources. Resources are wasting. I mean, wasting means not being used properly. So what is another thing also there? Let's say now I got a scenario that my my API is working fine. Here Java 15 is there, all good. Now another developer came like, hey, I want to run this VM in my laptop. Can you send that? Because he can install. I mean, the another developer, another guy, he can install by himself. Install a VM, download the OS file, ISO file, install the OS, install the platform, build the code, run it. Too much process, right? Since I have already a virtual machine which has everything inside it. My platform is Java. I mean, what is the platform to run your application? That's all we call it platform. So everything is installed. Even the code is there. I mean, my application is there. So you don't need to do building all these things from scratch again. Simply, I can share this and you can run it. So we can share it, but it is two time take process. I mean, sharing is easy, but as I told you, size is more, so it will take. Hours maybe, depends on the size. Obviously, it will be more than 5 or 6 GB, so it will take too much time. And how do you share? Through Teams or through Slack or through mail? No, right? So huge files, and you cannot share. So these are some drawbacks of VMs. So VMs is good. People still use VMs, but these drawbacks. Now what to do for this? And that's when they thought they brought a new concept called containers. Containers. Let's. What is containers first? This is not. So yeah, when I yeah, okay. Let's see. So what is containers are like? This is similar to VMs. This is similar to VMs, pretty much same. So what is the VM structure? You will see. Yeah, this is all right. It's downloading. Sorry, yeah, it's fine. So we have our host machine, our laptop, hypervisor software, and virtual machine one, two, three, four, blah blah, whatever it is. No matter how many. Containers also similar structure, but what is like advantage that is bringing us is whatever the drawbacks we just discussed, like speed, size of it, and as well as the resources not being utilized properly, and as well as the sharing is difficult, shipping the things is difficult. All those things in the container concept, all those things has been addressed. So all those things has been cleared, whatever the issues we're facing. So you can see the container structure is a little different. But yeah, let's not go here. Let's see first what is container. As I told you, it's similarly uh, similar to virtual machines, but the container it's like a what do you say? It's like a package. Let's say let's take a ship container as an example. We can compare that. See how the ship containers size, how it looks usually rectangle shape, right? Let's see. It will be in the same size. Unit. Google want my location or something. So yeah, let's take this. This is good image. Yeah. See, this is ship containers. If you observe here, everything in same size and shape. There is no difference. No differences in size and shapes. There won't be any square containers, cube, round containers, something like that. Everything will come in same size. But inside these containers, we can ship anything, right? Let's say on the first one, I put some clothes or something. In second, I put something, some vehicle or car or bike. In third one, I kept like helicopter parts. The content can be anything inside this, but the shape won't change. Depends on the content, right? It won't change. The shape is same. It's rectangular box. So, but we can store anything. Shipping this is easy, right? Let's say usually you might have seen some in highways. They'll take huge helicopter parts in the lorries, these huge trucks. It will be very huge. So that will be usually difficult. But throw that, the helicopter, whatever the part in here, container, because container the shape does not change. So it will just work as a container, that's it. No matter what's inside it. And it's easy to ship. And the size is same. Sizes won't be different. Size is same. Similar way, our normal container also. Similar way, our normal containers. So it's just like VMs, but with few advantages. So the advantages, what are the advantages? We'll see that. In a definition form, if you ask me, Containers are like the packages, right? I told you, right? The packages, which are like, but lightweight packages. The size will be very, very less. I'll tell you why it is less, but these are very lightweight packages. What since what will be the content inside a package? It can be anything. It can be your application code. It can be something. It can be OS, anything. So simply containers are lightweight packages where we can use them to build our applications or dependencies together. This container will run isolatedly. So now coming to the picture here, if you see what is missing here, what is the difference? If you might have seen, there is no guest OS here in the container. See, is there a guest OS? No. In the VMs, we are installing a new operating system. On top of that, we are installing the platform and running our application. Due to that, the size is huge. But in containers, we're not doing that. We're directly running on the host machine itself, I mean, on the system itself, the containers we're running without any operating system. But how? The container it'll use the host itself, host operating system itself. It doesn't need anything extra. There will be a software called Container Engine, similar to hypervisor, which will manage the containers. And the host operating system resources will be used for the containers. Let's say I created a container, I mean, virtual machine. I need to assign RAM, CPU, I mean, the resources to the for the VM separately. But in containers, I don't need to specify anything. I just simply run a container, and it will take everything from the system itself. I need 100 GB RAM, sorry, 10 GB RAM. It will take from the system directly. No need to assign. Same thing for container BC or something like that. The advantage what containers brought us is, what is the first thing I told, the drawbacks in VM? Size, right? Size is huge in VM. That's the drawback. In containers, size is very, very less. That's why I told lightweight containers, lightweight packages. Why lightweight? Why, how, I mean, how it became lightweight is, I told that, VMs, when we install an operating system, that's what we're doing. It will come with lots of unnecessary packages, even though we use some, but we don't use some. Due to that, size is less, huge. But in containers, it will give you what exactly you requested for. In the container, let's say, hey, I want to deploy Java. So it will give Java to you, not other things, just Java. If hey, I want Python, it will do just Python, not other things. You can ask like, hey, I want Ubuntu. It will just give you Ubuntu only, which are basic things required to run Ubuntu. That's it, not other than it. Due to that, size is very, very huge. There is huge margin for the for this size. As an example, I would say Ubuntu ISO image is around 4 GB something, 4.7 or something, if I remember correctly. But say Ubuntu container is around 64 MB. See the size, 64 MB, not even 640, 64. See the size difference. That much use, that much unnecessary things will be there. That much we don't use them. Even though there will be with some dependencies which we use, which we require to use, you can install the container itself if you need it. If you don't, you can skip it simply. So that's the difference. That much size difference. And due to the size is less, you can the performance the speed will be faster, right? You can simply create them. You can simply delete them. So it's faster. It will be obviously. And what is the third point I told? Resources are not being used properly in VMs, but in containers, it will use exactly how much is required. Container A, let's say, it required 10 MB. It will take 10 MB. Now after some time, it required only 5 MB. It will give back the remaining 5 MB to the back to the host. I mean our machine. So it will use the resources very efficiently. It will use exactly what is needed, not more than that. Same thing with the disk and everything. In the last point I told, uh, sorry, this one, shipping is difficult because if we want to set up the same environment in another machine, we have to ship the whole VMs, which will be different because we are shipping on operating system. But in container, there is no OS, right? Just in your application, I mean, just your the requirement of your application or your libraries and dependencies, whatever will be required. Size is less, correct? Obviously, shipping will be faster. See, 64 MB Ubuntu image, how much time it will take? Hardly 5 minutes. Hardly, if your internet is slow, not more than that. Within 1 minute, usually it'll we can transfer. But yeah, see, that's much difference. That's how the containers became boom in the market because of these advantages that it brought to us. You may ask, without OS, how a container works? It's using the host operating system. That's why this line is mentioned here. Let's say you run a container in the Windows machine. Container does not use host operating system, but there is something called kernel inside and an OS. You know what is that? Kernel. In Linux also we have kernel. VM Linux is a kernel. It's named after Linus Torvalds. I mean, he is the one who developed it. I don't go to Linux, yeah, sorry. So now here also, in Windows also there will be a kernel. I don't know the name exactly, but yeah, there will be a kernel. So this kernel is the one which brings all these features to the operating system. This is the main core component of operating system in order to run it. So the kernel, I mean, for VMs, since we are installing separate operating systems, it has its own kernels. It has its own operating systems. But containers does not have OS at all. Does not have kernel at all. It is just the host system, everything. That's why the size is less. And another thing is it's isolated. So similar to VMs, it's isolated. How it's isolated is, let's say I'm running Java 11 here. If I'm running Java 11 here also in the application B, these two does not have a conflict. Let's say I have an application. I need to run version 1 and version 2 both. In a system, we can't. It's not possible. Let's say in VMs, how to do it? We have to install two VMs. In the app A, we have to define the version 1. Here version 2. Here version 3. So three VMs. But in here three containers, simple. Version 1, version 2, version 3. These two does not have any issue, because they are running isolatedly. So no one have the conflict with other containers. Let's say you're running 1,000 containers in your system, and none of them will have a conflict because they're all running isolatedly. Because our system kernel have the option to isolate it. Automatically, we don't do anything for that. So there is something called namespaces feature internally, which will use by these containers to provide the isolation for your containers. And sorry, yeah, that's about the containers. That's the intro of the containers. We haven't gone to our topic yet. We'll don't worry. So hope it is clear until so far before going. Any doubts so far? Anything? I know it will be a little confusing for me also same when I learned 7 years back, but it's very good actually. When you start working on it, it'll be too good. So just you have to know the concept of it, why it is required. They'll get a night then remaining all these whatever we do inside this container uh, tool. It's not really difficult. All you have to do understand the concept to why the containers are required because it's very common question actually. What is the difference between virtual machines and containers? If you know the idea of the containers, it's easy to tell this answer this question. But you just by head some points, so that's wouldn't be the case. So, but very easy actually. Let me tell you, one of my favorite tools actually. So all you have to know is why the containers, why it is required. So only that. So let's Until now, we have discussed what is VMs, what is containers. Okay, all good. But what is Docker here? What is this? I mean, where the Docker is coming in the picture here? Correct? Where and why? So let me just a minute. Let me I think my power gone. Come on, come on. Just a minute. Just a minute. Just give me 1 minute. Just a minute. Just a minute. The right time there is but in the power, not sure why. Thanks to Congress government. Come on, come on. Uh, come on, yes, yes. Yeah. So yeah. Can you hear me now? Sorry. Yeah,
Yes,
sorry, my power gone. So yeah, yeah. So I have to reconnect. Let me share again. Can you see my screen?
yes,
Yeah.
visible.
So yeah, I was talking about where Docker comes here, where the Docker concept is coming. Docker is something, used to manage the container. We were discussed what is container. I told them like the size is very less. We can ship them easily. We can create them, delete them. The speed is fine. But how to do all those things? That we'll be doing with Docker. Docker is nothing but a software actually to manage our containers, to build our containers, to run them, delete. I mean the actions whatever manage comes up only. So to do all those things, Docker we will be using Docker. So is there any other thing apart from Docker in the market? Yes, there are few things. There is something called Container D, which is famous. Podman is one of the things. So there are multiple things. But why Docker is I think first one which comes into the market, and as well as it is very easy to use and very easy to understand. So even a beginner who knows nothing about containers, who know nothing about DevOps or something, they can start working on Docker easily if he understand why. I'm telling again. So Docker is you know it's a platform or a software you can say. Just like I told, right? So if you want to run Java application, you need Java, right? Obviously. If you want to run a Python application, you need Python, correct? Now here Python or Java is the platforms for you. Similarly, Docker also. If you want to manage containers, you need a platform. So I'm choosing Docker as my platform. So Docker is a platform actually, a containerization platform, and of course open source too, where we can use this Docker, to manage our containers. So that's what Docker is about. So that how to use Docker is you just have to install Docker. That's it. Just a single command. If it is Linux, it's just a single command, apt install or Docker or yum install Docker, something like that. If it is Windows, there is something called Docker Desktop. You have to download the Docker Desktop and you have to install it. So now for me it will be difficult to download the Docker Desktop because sorry I can't see my keyboard because it's around 500 MB, so it will take too much time. But let me show you Docker Desktop for Windows. For Mac also there is Docker Desktop. You can use command line also. But for Linux, Docker single command you can use. Let's install that. I started. Let it load. It's a mobile network, obviously. So download for Windows, download for Mac OS also will be there. Download for Linux. So in Linux, obviously, we don't use UI, correct? So Docker, this is how Docker desktop looks like. This is, it's a UI. I mean, we can use CLI also, but it also gives you UI like this. See, forget out what is all these things. We'll get there on the tutorial. But yeah, this is how it looks like. But in Linux, we don't have any UI. We don't use UI. We'll use commands to manage the containers using Docker. For God's sake. So since we are working on Linux machine, we'll see how to install in Linux. So Windows also not much difficult. So just download this package. I think it will be 500 MB. Download it. Next or something. That's it. It will just it's easy. I mean that's all I want to say. So let's install. Let's install. Yeah, it's running. Let's log into the machine. Oh my God. Let's let me log in. Yeah, yeah, I logged in. Let's do apt update. Yep. Now let's install Docker. It's simple. That's it. Now it is not. Docker.io. Yes, let's enter. That's it. I think it's installed. How to see? Docker will be running as a service. Systemctl status Docker. Is it running? See, actually, see. Let's enable this. So that's it. Installing Docker. But sometimes what happens is, what happened is like the Docker package is available in the apt repos by default. So that's why if I do just apt install docker.io, it works. But sometimes in the repos, I mean, apt repos, Docker package won't be available. At the time, you simply add Docker repo and install it. That's it. So you can try it like that also. There is an official document I forgot to mention. Docker official website is there. The documentation. So you can find everything here, how to install and everything. Guides. Let's go to manuals. Hmm. Let's see how to install. Here it will be install. Desktop. It will show you how to install. Just install on Ubuntu. See apt install. These commands. Don't worry about that. But when the latest version of operating systems, let's say in Ubuntu 18, from 18 or CentOS 7 or 8, 9, so Docker is available by default. I mean, you can simply install it. It's available in the packages. But if not, these steps you have to follow. Let's say you want to install a specific version. You remember the command apt cache This one docker.io 24, 20, these three versions are there. We can install anything. What is the current version? We haven't checked yet. Let's not check it for now because the commands and everything will start tomorrow. Today we'll see another topic. So yeah, that's how you install Docker. So let's see how container works. How container works. I mean, what is the Docker architecture? How it works? Let's see that. Let's go to image. It will be easy for you to understand. A simple image. Yeah, maybe this. I think this will be same in official website also. But let's see here. Okay. Somehow it loaded. Where is the image? It's not loaded. But yeah, at least medium. It should be faster. Yeah. So can you see the image? So this is how the architecture of Docker looks like. So let's start from Docker client Docker CLI. This is nothing but our command line. We give some Docker commands. That is where Docker CLI or Docker client usually be. Just like this is the client. If I give some Docker command here, what happens? That's how the architecture is. If I wherever I type my Docker command, that is the Docker CLI Docker client. Now if you type the command, what happens is there's something called REST API if you see there, which will take your input from the command line, gives to the Docker daemon. Docker daemon, it's a service which is running on your host. Just now we have seen, right? Systemctl status. It's a service or a daemon. Usually we call it a daemon. So when we done run any Docker commands, it will Docker CLI will take the input, translate into an API call, and send to Docker daemon. So we ran Docker command here. This will take it, the input, convert it to the API because Docker we gave some command. It won't work, right? System doesn't understand that. So it has to say in system format. Then only it will understand, correct? So REST API takes the input, gives to Docker daemon. Docker daemon is service which is running, in our lab server. That will take the input from REST API. Okay, this guy wants something, and it gives the output back to REST API. And REST API backs to Docker client in a readable format for us, human readable format. That's how usually it works. So this is forget about the four components what is here. I'll come one by one, but for now overall this round option, this round figure. This is the architecture of Docker. It's simple. Three components only. One is Docker CLI where we give our inputs, nothing but our command line CLI. REST API is the one which takes the input. So since the Docker daemon does not understand the direct commands, it will take it, convert into an API call, and send to Docker daemon, the service. Service take the input from the REST API. Okay, the user wants this. He'll send the response back to your API, and the API send the response back to Docker client in a human readable format where we can understand it. Because that we are the ones right who hit the command. That's what. That's how the Docker. Uh, Sorry, that's how the Docker architecture looks like. Now let's execute a Docker command. Let's say all Docker commands start with Docker, obviously, just like GitHub, Git something, maybe an ambient something, correct? That's what we did. Right? Similarly here also Docker commands will start with Docker. And you can use the parameters, whatever. Let's say my version I want to see. What is the version? See, 24 it seems on Ubuntu 22. This is my 22 Ubuntu 22 version, like this. So Docker have a home directory where it will store everything in that. Do any of you remember what is home directory of Jenkins? It's varlib Jenkins, right? Similar to Docker, varlib Docker, varlib Docker. By default, there will be something you don't understand. What is it now? Sorry. When the topic comes, we'll cover all these things. But for now, this is a directory. There is some content inside it. You simply do this Docker info. It will show you, sorry, my keyboard. It will show you all the information about Docker you just installed. What is the version? Whatever version, so many things. Sorry, just one or two comments I'm just telling you today before closing. So now coming to the components in Docker. So this is the architecture and these are the components of Docker. Let's start with image. Right of it. How to describe the image is it's like a package actually. Where it's like let's say template. Anything I mean. So what you do is you keep everything whatever you want inside this package, right? And you run it. Let's take an example of a zip file, zip file or tar file. You take multiple files and we zip them together, right? Now it's a package. The content whatever is zipped inside it, we can't see until we extract it, correct? Similarly, Docker image also. Image is like a zip file, simply to keep it packaged, where we store everything inside this image. But what we store and how it will be used, what we store is whatever based on our requirement, our application code. As I told you, I want to run my Java 15 application in container. So what I do, I'll keep my Java platform, Java 15, my source code, my dependencies, whatever libraries, into a package, into a single package. See in the Maven, why you build the code? Because you can't deploy all those files. You build a single package, artifact, jar, var, similarly here also. With all our dependencies, we are building a package so that we can run our application inside a container. That's what we call a Docker image. It's nothing but a package where we store everything whichever required for our application inside this image and we run it. Just like a zip file, simple, to keep it simple. Next thing, what we do with this image? We create a container. This is how to create a container. Containers are nothing but once you create an image, I mean the package, you have to run the package because let's say in my zip file I have everything, right? My files are there, every data is there in the zip file. Unless if I extract it, will it show me the content? No, right? I have to extract it somewhere. Means I have to execute that. Then the action happened, the extraction happened. Similarly here, you kept everything regarding your application, whatever it is, Java 15 or Python something, inside this image. Now if you execute it only, whatever inside it will start, whatever inside it will work. So when you execute, what happens? When you execute a zip file, it will unzip. When you execute an image, it will create a container. It will create a container. Now what's inside a container? What's inside the image? You want to run your application, correct? That's what you gave. That's what you told in the image. So now it means The container will create, and inside that, the application will start. So containers are nothing but, to keep it simple, it's like a running form for the image. Simple to keep it like that. We run the image, or sorry, we execute the image, let's say, for now, and the container will start. Whatever inside the image will start running if it is everything is correct from our side. That's about Docker image and Docker container. See, we discussed what is container. The same thing here also. Same thing. We're just using Docker to manage the container. That's it. So that's about images and container. Let's take an example. You got a package from Amazon. It will be packed, right? Sealed. And whatever the content inside, you have to cut it to open to see what's inside. Similar, the package is nothing but image, Docker image here, where every content is inside that. I mean, the Amazon guy kept everything inside the package, the image in our case, and we cut it open. We see what is inside. If we are doing some action in order to see, in order to take whatever inside. Similarly, in Docker, we packing everything and we are executing the image, which creates in the containers. What will container do? Whatever inside it, it will run. Whatever you kept inside, whether it can be anything, it does not matter what it is. Anything. If you write some ls command in the image, it will run the ls command in the container because container starts whatever inside, it will start whatever inside. We'll come to more of container images when we start the commands. Don't worry about all those things. Okay. Now these network and volumes are separate topics, but we will have few. We'll discuss about these things just for at least for basic level understanding. So volumes are nothing but data volumes, nothing but to store the data. Simple to store the data, we create volumes. We use volume just like hard disk. We in our laptops we have hard disk right, to store the data. So if the system corrupts, you can take the hard disk out. If it is not corrupted, you can use it without some other system. Similarly here also, Docker have volumes where we can able to use it. Similarly network. Network it means Docker have its own network by default. In your laptop there will be a network obviously, correct? When you connect to Wi-Fi, something or network, there will be some network. Within Docker also there is a network. So now we are installing Docker in my laptop. So I have my host network, I mean my laptop network, my machine network. Inside the Docker network also there. So this Docker network, what it will do, it will assign IP address to containers and everything. It will manage the networking part. Again, I told you, right, this is a separate topic, just one line I just told you. Just to at least understand what it is. Oh, I think it's too much today. So that's fine, yeah. That's it for today. So we'll see. I think we discussed about what is what. As I told you right again, if you know why it is required, all these will be easy. So keep in mind that why why in the first place this concept called containers came, but why Docker, all these things. But why we are not using virtual machine? I mean, people still use virtual machine, but they use Docker hugely, heavily. I'm telling you, that's okay. Even if you want to run a container, you need something, right? You need an OS. Obviously, the virtual machines are your laptops or something, anything. So it's not like a bad thing that virtual machines something like that. Few drawbacks. Docker came like that. Docker came with these, addressing these drawbacks. I want to tell one thing like Docker is not replacement of virtual machines. No, they're two separate. It's similar features. That's it. Two separate platforms, similar features. Well, Docker have more advantages. That's it. So yeah, that's it for today's class. Tomorrow, today we see I think installation also. So try that. Try to execute some command, Docker version, Docker info, something which I just showed you. Tomorrow we'll see some. We'll start with basic commands. which are the very basic commands, and slowly we'll go. What is image? Again, we'll see. Definitely, don't worry. What is image? What is container? How to create them? I mean, how to use them exactly? What is everything? And of course, one last thing before closing. Yeah, that's okay. We can discuss some other time. No problem. It'll be too much today. So yeah, that's that's it. So any doubts before closing?
Bro, can we install this Docker in the same instance
As I
where
said,
we run Tomcat, Jenkins, Maven?
it's just a software, as I told you, right? You can install anywhere. Does not really matter.
Yes.
Just like software, just like Jenkins. It's sorry,
Okay. Okay. No, I thought that those concepts also will be used
we'll
in
use
in this
obviously.
Docker
We'll use obviously. Yeah,
session or
you can install anywhere. It does
okay.
not matter. See, Maven or Git or let's say Sonar. These are all tools, right? We installed it in order to use it. Docker is a tool, just another tool. That's it. It's just another tool, not specifically something. Just another tool. That's it. You just install it anywhere, laptop or easy to or somewhere wherever it is. That's fine. Got it? Any other doubt?
Yes, bro.
Any other? All
No.
right. So then, yeah, we'll close the call today. I told you right in the group. So tomorrow, Tuesday and Wednesday, same time. The class will be at same time, 8 o'clock. Morning, I have different meetings. So from Thursday, we'll continue our usual time. But for 2 days, next 2 days, it will be same time, 8 o'clock. Okay. Yeah, the video will upload a little late
Okay.
because my internet is slow.
Okay.
So, but I'll upload today itself. So yeah, that's it from my side. Thank you all. Bye.